All right, fifth and sixth, no, not sixth, be seventh and eighth graders actually. In your book, the eighth grade book, you should have access to that on flourishkh.com, and you should have your login information on that. This would be the eighth grade book. You should find it there. This is page 366 through 373. How does the earth change? I just want to hit some high spots of this, not cover everything. You can read it, but just to highlight some of the things. So first thing we want to do is here at the bottom, summary of the earth's layers. So you should know there's a crust, mantle, and core. Core is in the middle, surrounded by the mantle, and on top what we live on, the crust. So the core is the inner core, actually two parts of it. One is very solid, the other one is liquid. It's all metal, and that's why we have magnetics around the earth, magnetosphere we talked about before, and gravity. The pull of that power comes from the metal in here and the mass of it. Mantle, some of it's partially molten, another one is mostly solid yet, and then the crust on top, which is solid. It floats basically on the mantle. All right, so you got your three areas that you need to be considering: crust, mantle, and core. Okay, so if you're taking notes, you should be making sure you understand those three. All right, back to the book. Tectonic plates. Now you know that is like an eggshell, right? Eggshell, you crack it in places, all those pieces, when it stays on the egg anyway, kind of floating over the top of the solid part. That's just the way the earth is. So the crust is, and part of the mantle below it, would be into big chunk pieces that float on the liquid mantle below it. Now these pieces rub up against each other, and voila, as they try to move, and they do try to move, that's where we get earthquakes. And at these zones that you see in the book here on the blue lines, that's where also you get volcanoes tend to be in those spots as well. So tectonic plates, that's another one you need to write down. Make sure you understand that one. They do move in different directions, and that is what's responsible for a lot of the changes that happen in Earth history as far as what the land looks like, is a major contributor to that. So another one we need to write down. Tectonic plates. Okay. Sorry, the book about fell off my lap. All right, next page. Things need to look at. We talked about this before, but there's basically four types of movement. And I'll just put it with arrows on the board. So one type of movement is where one tries to move past each other that way. The next one is where one will flow under the other one. And sometimes you get mountains build up in this part. You also have where they meet like that. And instead of one going the other, they both push up. So you get mountains. All right. Then you have one that's on the ocean floor, usually. I don't think we have any on land. And that is when they both, oops, sorry, I got to redo that. They're moving away from each other. So this spreads here. That's where lava can come up and form new crust. That's usually at the bottom of the ocean where those spreadings are happening. The other three usually happen on top of the surface. All right? We did talk about that before the break. All right. Over on page 370, it talks about supercontinents. And it mentions two of them. I'm just going to mention them. You don't need to write them down or anything. But one we haven't talked about, Rodinia. That's what they thought the first supercontinent was, where all these continents fit together basically in some way or form. And they said that's in billions of years ago and millions of years ago, which we know isn't accurate. And then the second supercontinent that formed, I think, is Pangaea, also several million years ago, which we know is not true. Now, how does the Earth change in its shape, in its landscape? Well, three major ways: weathering, erosion, and disposition. All right? So, next one you should write down is weathering. And weathering, as their book says, is the process by which the rocks and other materials in the earth are broken into smaller pieces by physical process or chemical change. So it's a breaking down process. Then comes erosion. Now that those things are broken down into smaller pieces, they're carried away. And that's what erosion is, either by wind or water, or by gravity that can pull it down. Now, where does it go? That's deposition. Where does it end up? It's carried and then dropped somewhere and left off somewhere. That's deposition. All right. Next page, 371. 4 major forces that cause the earth to change its landscape. And that's gravity, which we just mentioned. As things loosen and get weathered, they get into smaller pieces. Just gravity itself will pull it down if it's up on a mountain or something like that. Something may just fall apart. It will fall down. So there's where it's the deposition is. Anything with gravity falls down. Glaciers, on the other hand, huge sheets of ice that maybe covered a whole land, or maybe like alpine glaciers, they're in the mountains. They're like bulldozers, massive bulldozers, pushing everything in front of it. So that's another way. Now, when they're gone or melted, what's it like behind? Well, land is different. Water fills holes, things like that. But where did this stuff go? Out in front of it. That's where it was, that's deposition is out in front of the glacier and along its sides. The next one is a wind, and that moves things very little at a time. As particles float in the air, it can be like a sandblasting. There's little particles blown by the wind. So they end up wherever the wind quits or dies down. They fall. That's where deposition happens. Last one is water. We've talked about the power of water before. That moves things slowly and quickly, depending if you have a flood or just a regular river. So whenever the water slows down or the river widens out, which can make the water slow down, that's where it will dump all the stuff that it's carrying. So it will have a deposition in those areas, which tends to make the water more shallow. All right, next page, 372. A few things here. In conclusion, principles of original horizontality. Say that fast 5 times. That just means that as a result of the flood and as the waters calmed down, as heavier things sank first and then a little bit lighter and a little bit lighter, they were laid down in layers, one on top of another, fairly flat. The principle of lateral continuity just says that as something is spread out or deposited over a large area, as it settles, it will tend to spread out to the sides. Okay? And the principle of superposition. This one a lot of scientists like to use to show the Earth is very, very old. It just means that as the bottom layers of rock should be older than the top layers of rock. Well, that may be true in some places, but with Noah's flood and what it did to everything, turned everything upside down, you can't always count on that. So to compare one layer to another, sometimes it shows that the top layer is younger, but that might not always be the case. Okay, last page over here. So you can see the diagram here too. So we do have rock layers, but think of it like a peanut butter sandwich. So you make the sandwich, it's got layers, the bread, the peanut butter, the jelly, and another layer of bread. Now cut it with a knife. When something cuts through the crust like that, it's called an intrusion. What causes that? It'd be an earthquake could cause that. It causes a seam or a fault to open up between two sections of land. And oftentimes that fault will be filled by a volcano. So some kind of lava comes up through there, and if it spills out and cools off, you have a new layer of rock. So that intrusion area is oftentimes the youngest rock, younger than the other layers that it cut through. The last thing here showing is called nonconformity. That is, sometimes layers were laid down and they were eroded pretty fast by something, even before the next layer started to be laid down on top of it. So you're actually got to have a gap. There was something laid down, then it was eroded away, and then the next layer came down. So you're missing a layer. That would be unconformity in the geological record. So it's a gap of time. All right, that is a quick tour of this lesson. I hope you read it all first, then you can watch this video. There are no questions to go with this part, so you got lucked out right there, didn't you now?